Hello, fellow participants. I'm very pleased to have the opportunity to introduce Jan Dash. He's a worldwide expert in, in climate risk and all things climate finance oriented and beyond. He has a long history being a rocket scientist on Wall Street, and he's a Gabelli Fellow now, helping us out develop some climate courses here at the Gabelli School. And I'm pleased to introduce him. And Jen, why don't you take it away?
Okay, well, thanks very much, Steve. I appreciate that. And thank you for coming out on Earth Day. Happy Earth Day to everybody. It's a beautiful day out, so I know that, coming to listen to somebody talk about climate change when it's a nice day is shows your dedication. So anyway, so thank you for being here. So what I'm going to do is really give an overview. I hope you can all see my slides, yes? And hear me, yes? Okay.
Yes.
So I'm going to talk about climate change, opportunity, and risk. So can you also see my cursor?
Okay. Yes.
So I like to emphasize the opportunity involved as well as the risk. Usually people talk about the risk. I put opportunity first because I believe that is really the crux of solving the climate problem. So to start off, I have a quiz, okay? And it's not going to be a poll and there's no grades or anything. But I just wanted you to ask yourself, what do you think about the opportunities and risks involved with climate change, okay? Just ask yourself the question. And I'm going to come back and revisit this quiz at the end of the talk. So I want to give you the bottom line right up front. For opportunity, there are tens of trillions of dollars of business investment and operations opportunities in solving the climate problem, plus many co-benefits, which are there as well. And so that's the opportunity. What is the risk? Well, the risk is a potentially disastrous damage to the human race if robust climate action is not increased substantially starting now. And that's not an exaggeration. Climate change is already damaging and costing a lot of money, but this is just really a preview of what is coming down the road if we do not substantially increase our climate action now. And one thing I do want to emphasize is that there will be jobs, lots of jobs, in what I call climate change risk and opportunity officer jobs at a high level, as well as other levels. And so that's something that I believe has started now, and it will become soon, within the next couple of years, I believe, commonplace. So that's the bottom line of the talk. So here's an outline of the talk. So there's going to be two parts to it. First, a part one, which is review and an introduction. Now, you may already know a lot of this, but some people may not. And just to see if make sure we're on the same page, I'm going to give a review. It's not very long, about 30 minutes. And then we'll take some questions. So if you have questions, please write them in the chat. So that'll give you an opportunity to think about what questions you want to ask. And then Devin will ask me the questions. So that's the format I'd like to adopt. And then so we'll have some questions, maybe 5 minutes or so. And then for part two, what I'm going to do is to go into some examples of climate action, again, for about a half hour. And then we'll have some more questions and open it up to discussions after that, which will be kind of an open mic. So you can, say whatever you want. And then there will also be, I also have an appendix, which is really there for reference. I don't have the time to talk about it, but it's a kind of a deeper dive, and there's some information about models, climate models in there. And so I think that this talk, the PDF file, will be available, and so you can, look over this material after it's posted. Okay, so this talk is an overview. It's an overview, and each slide that I'm going to show, there are a lot of slides. I just want to say that each slide itself needs about an hour to discuss the details, which of course I don't have the time for. But just to let you know, this is an overview, so I'm going to try to give you a broad brush overview of what climate change is. So what are the issues for climate change? Well, the best way that I can describe the issues is to categorize them in 3 classes. And these classes line up with reports, which I'll describe as the talk goes along, by the Intergovernmental Panel on Climate Change, or IPCC. The first is the physical science basis. So what is climate science? The second are climate impacts. And when I say climate, I mean climate change. Climate change impacts, adaptation to climate change, and vulnerabilities. And the third is mitigation of climate change. That is, making climate change less severe by acting on its causes. So what is climate change? Well, climate change, you can define it simply as the set of changing climatic phenomena which is time averaged over, let's say, 30 years. And 30 years is a good number to use because climate change has been changing so quickly. What is global warming? So you may have heard of global warming. Global warming is the upward trend of global average temperature of climate change. So there are fluctuations about this trend due to natural causes, but global warming is an upward trend. And it's due to humans, basically. So I'm going to be talking about that. And the biggest concept that I want you to come away with is a carbon budget. So carbon budget, so what is that? It's the maximum amount of carbon that we can have in the atmosphere and still have a livable world. Okay, so there's a maximum amount of carbon. Carbon dioxide stays up in the atmosphere for a long time, so there's a carbon budget. So that's the big conceptual thing that I want you to understand. So climate action is urgent. So I have a vision, which is to make and keep a livable and just world. What is the mission? That's a state. What is the mission? It's action that we need to achieve the vision, and that's to, in quotes, eliminate carbon emissions. So eliminate means with all deliberate speed. So that's basically what the word eliminates, but that's basically what we have to do. And the carbon emissions are mostly carbon dioxide. So 1 atom of carbon, 2 atoms of oxygen, and a molecule, carbon dioxide. And then there are other gases, for example, methane, that leads to a concept of something called CO2 equivalent, which I'm not going to really talk about, but the one-liner is carbon dioxide. So again, there are huge opportunities in carrying out this mission, which I'm going to emphasize over and over. We need more climate risk management for bad possibilities. Right? So that's what risk management is. We take account of bad possibilities, we plan for it, we hedge against it, and climate risk management is risk management for climate change. And there are 3 words that I like to emphasize, which are necessary attributes for climate action. One is optimism, one is courage, one is persistence. And I'll come back to these at the end of the talk. So the top line is that global warming is the most severe long-term survival and justice issue facing the human race today. I'm a physicist. I'll just say 1 or 2 words about the science, and basically it's the science is clear. And in the field, experts do agree on this statement, that the global warming trend of climate change, it exists. It came out of the noise around 1975. It's mostly due to carbon dioxide emissions from burning fossil fuels. Now, the story's a little more complicated, but that's the one-liner I want you to keep in mind. And again, the carbon budget is the important conceptual thing, and it's a physics constraint. It has nothing to do with politics or anything else. It's just physics. Carbon dioxide stays in the atmosphere a long time. There's a maximum, and it warms the planet. because of physics, and so the physics of the carbon dioxide molecule tells you that there is a carbon budget. It is a survival issue. So we've always had disasters, but they're simply made worse by climate change, and there are many types, and I'll talk about them in a second. Impacts are being seen now, but the warning is that the impacts can and will get much worse if we do not act more substantially soon. We're already acting, but we need to act more. And we have very little time to enhance climate action before the world gets into a state which is really bad. There are justice and ethics issues. So climate justice, what is that? Well, vulnerable and poor people have very few resources. They're poor, so they don't burn much fossil fuel, so they don't contribute much to climate change, but at the same time, they have very few resources to adapt to climate change, and so that's a justice issue. The correction of that is climate justice. There's also a generational issue, intergenerational equity. That's our grandchildren and so forth, and who've done nothing whatever to cause this problem, but will suffer the most if we continue to kick the can down the road as we are essentially doing now. So the carbon budget is basically who gets to emit what emissions consistent with the carbon budget. Okay, so these are the justice and ethics issues. But lest you think that only poor people are being affected, there will be no place to hide for anyone if climate change gets much worse. Okay, so that's the top line. So to give a scale of the problem, the carbon dioxide in the atmosphere now is the highest it's been in 3 million years due to humans. And the weight of carbon dioxide emitted per person per year globally is 1 elephant. Okay, so that gives an idea of the scale of the problem. So climate is a human survival issue. So here are all of the disasters that are made worse by climate change, and I'm just going to read them. Each one is a separate lecture. More crop failures, worse freshwater shortages, sea level rise, ocean acidification, more intense fires, worse extreme weather and hurricanes, more drought, more flooding, more severe heat waves, more disease, severe species extermination, more political instability and loss of civil rights, more climate migration, and increased conflict. That means increased wars, national insecurity, and terrorism. Okay. Now I want to emphasize one for this, especially for this audience, is that there will be economic and finance system systemic disruption and possible breakdown. Okay. There are tipping points. That means going beyond points of where we can really, do something. Some of these things are irreversible. Moreover, there are feedbacks between these various kinds of disasters, so they're not simple. And I won't have time to talk about it, but if you ask me questions, I can talk about it. Is that there are attribution studies from climate models for discussing how much influence global warming has on these various kinds of disasters, and they're getting better. Okay, so climate is a human survival issue. What are the climate risks to businesses? Well, they're all the risks I just talked about, plus reputation risk, that's loss of social contract, regulation risk. So regulations are coming. They'll be in Europe first, but they are coming to the US. There's a transition risk to a renewable economy. That means stopping burning fossil fuels, and there's a risk in that transition. There's technology risk, which is enhanced because of that transition. There are stranded asset risks. We cannot burn all the carbon that's in the ground, so we cannot burn all the fossil fuels that we know we could burn. And there's lost opportunity risk, amounting to trillions of dollars, which could happen. And there's also a contagion risk up and down the supply chain. And again, each one of these is a separate lecture, but I'm just listing them. And again, the worst risk may actually be the induced instability of financial and economic systems. So I believe the financial and economic systems are in fact unstable. They're in unstable equilibrium, and climate change can knock them apart. So I do want to mention the Sustainable Development Goals up front. So these, especially for this audience, so all social justice issues described by the Sustainable Development Goals, if you don't already know about them, I urge you to learn about them, are tied together with climate action. So Sustainable Development Goal number 1 is no poverty worldwide. Okay, so these are goals to which all countries have agreed. They were formulated in 2015. Climate action is number 13, and people who discuss the Sustainable Development Goals and these social justice issues say that there is no long-term solution to any of them without a solution to climate change. So that's all the bad news, okay? Now there's good news. The good news is we can, in fact, mitigate climate change. We really can. With the technology that we have now. New technology will help, for sure, but we don't actually even need it. We can mitigate climate change substantially with the technology we have now. What we have to do is apply climate change risk management. There are all kinds of risks. We deal with them every day. Business deals with them. What we need to do is view climate change as risk and apply risk management, climate change risk management, changing with all deliberate speed from fossil fuel use to renewables. And we need action at all levels, from local to global. So that means individuals, NGOs, that's environmental groups, faith groups, investor groups, academia, for example, Fordham University. It means businesses are going to play a critical role in mitigation, and all governments at all levels. That means cities, municipal governments, states, national governments, and international agreements. Okay, so we all have to act together. One thing that I like to emphasize about climate action is the word "and," not the word "or." Okay, so again, we're acting to make climate change less severe, trying to mitigate climate change. It's substantial now, but we just need more of it. And the word "and" is that there are 100 different kinds of actions for climate, and we basically need all of them. So if somebody says, well, you know, take that example of action, it's not going to work, it's not going to solve climate change, they're probably right. What we need is a portfolio of actions. Okay, there's no silver bullet. So I'm going to talk about that in the next part. I do want to mention up front that a price on carbon can and will stimulate climate actions of these various types. It's extremely important. So we're not going to be able to mitigate climate change completely, so we're going to need to adapt to the impacts of climate change that we can't mitigate. And with increasing resilience, that means the ability to adapt. So business is key for climate action. We need a certain number of trillions of dollars for the renewable economy. The number of trillions depends on the estimate, but the scale is trillions, not billions, but trillions. Private capital does have the scale of trillions of dollars to deploy. Governments don't have trillions of dollars to deploy. So that one statement tells you that businesses are the key for climate action. Okay, and just so you know, a renewable economy is now unstoppable. So it's going to happen. Private capital is going to play the major role. So how is that actually going to occur? Well, we actually need both government and business to step in. For governments, what we need is to set policy, reasonable policy, tax policy, reasonable regulations are absolutely needed, and to deploy dollars to really stimulate the start and the continuation and the increase in renewable economies. Okay, so business, that's critical for that to happen, for incentives. Businesses are then going to have to come in and do the heavy lifting because they have the trillions of dollars in the scale that's going to be needed. There was some really good news announced by Mark Carney, the former chairman of the Bank of England, last year at the climate conference in Glasgow. A new organization called GFANZ, which is committed to managing assets totaling over $130 trillion. That's the right scale. That's their assets under management. In line with the goal, which I'm going to talk about, of 1.5 degrees centigrade increase in temperature worldwide. Okay, so that's good news. So business is stepping up. And again, once more, lots of opportunity. So jobs and climate risk management. Yes, there are going to be jobs in climate risk management. So what I call climate change, opportunity, and risk management to help especially businesses, but also governments and academia, understand what the risks are and take advantage of the opportunities that I just discussed. These jobs are now underway, and they will become the norm, I firmly believe, within the next few years in corporations, Wall Street, government, and also academia. Okay, so here's a statement from a report from the CFTC that I urge you to have a look at. Climate change poses a major risk to the stability of the U.S. financial system and to its ability to sustain the American economy. That's what I just said. Okay. You may have heard of the TCFD, which is the Task Force on Climate-Related Financial Disclosures. It's an effort that was led by Mike Bloomberg. When I was the head risk quant at Bloomberg, I actually had contact with the secretariat that was leading that effort, so I know something about it. These are guidelines for climate risk reporting and also action by businesses. Right now they're guidelines, but they will become regulation. So climate is a top risk, everybody. So there's a beautiful place in Switzerland called Davos, and there's something that takes place there every year called the World Economic Forum. The leaders in finance and economics go there, right? Every year they publish a report. The report is what are the main risks that facing the world in terms of big picture things. So for long-term risks, impacts over the next 10 years, here are the two most likely: extreme weather. Increase in extreme weather is connected with climate change, and climate action failure. They're regarding that as a likely risk. Hopefully not, but that's what they say. As an impact, what is the biggest impact? Climate action failure. Again, so 3, and the second is weapons of mass destruction. So 3 out of the 4 items of top risk are climate change related. Okay, so I do want to mention just a couple things about why I believe the climate system climate impact can make finance and economic systems unstable. Well, the transition risk from fossil fuels to renewable energy is a biggie. So resolving supply and demand imbalances, making sure that firms that need to stay solvent in this transition. That's a big risk. Second is the myriad severe climate impacts that I've just talked about. Okay, one example is PG&E. Whatever you think about PG&E, its task was made much more severe by fires that were made worse by climate change. It's not bankrupt. And one thing that it doesn't get enough attention, but I think is a huge risk, is if we do not act enough, our descendants are going to have to over leverage, that is, borrow money to cope with climate impacts to try to adapt to it, leading to instabilities in the financial system. These are just 3 reasons, but there are many others. Okay, I do want to just show you some data, just so you see it, in different scales. This is today. This period here is the period of civilized human activity over the last 10,000 years. This is the temperature. It's remarkably stable. We are moving out of that temperature region. See a little fluctuation? We're moving out of that region. Now the temperature is higher than in the last 6,000 years, maybe more, and it's moving incredibly rapidly. So we do not have experience outside of this region where humans started with cities 5,000 years ago, developed agriculture and so forth. We're moving out of that region. Now, if somebody tells you nothing is going to happen, you show them this graph and you say, well, how do you know that? Right? And this is the prediction with different scenarios that show how temperature will evolve depending on what humans do. You have to go back 3 million years to get to temperatures that are the same as the temperatures that may happen. Okay, so what are some of the co-benefits? I'm just going to run through some examples. You probably have heard about them, but just to show you, climate action has co-benefits. Reducing worse extreme weather. Hurricanes, big hurricanes are known to have their severity increased by climate change. Acting on climate change can reduce the impacts of hurricanes. Reducing sea level rise. The U.S. Navy runs predictions or projections of possible sea level rise between 1 and 2 meters. That has huge impacts on cities that are coastal cities and by reduce and sea level rise due to climate change. So we can reduce that by acting on climate change. Reduce suffering. Here are some pictures of people coping with the effects of Sandy and Katrina. Just reducing suffering is another co-benefit of acting. Health impacts are huge. The American Public Health Association has said publicly that they regard climate change as the worst risk to public health in the 21st century. This is a matrix of climate impacts and health risks. You don't have to read anything. All you have to do is look at the check marks in this matrix. They're all over the place. There is a big, huge risk to health. The U.S. Defense Department issues reports talking about climate as a risk multiplier, and talking about the security risks involved in climate change worldwide. Acting on climate can reduce these security risks. Climate migration is becoming bigger and bigger. If you go to Latin America, some of the countries in Latin America, places in those countries are now unlivable, partially due to climate change. If we do not substantially act on climate change, and if you think climate migration across the southern border is a big problem now, you haven't seen anything. It is predicted that if we do not act substantially on climate change, climate migration will amount to hundreds of millions of people. That will destabilize governments all over the planet. There are studies, county by county studies, with showing that as temperatures get above a certain level, plants producing crops turn off, both C3 and C4 types of plants. That leads to projections of reductions of major crops, which, depending on the study and what happens, between 20 and 50%, maybe more. That means hunger. Fires are out of all statistical measures now, and it is known from attribution studies that climate change impacts intense fires. Acting on climate change will reduce that risk. There is now a water shortage in the southwest United States, which is unprecedented in the last 1,200 years. It is projected worldwide by climate experts that between 500 million to 3 billion people will be short of drinking water by the end of the century if we do not act more. So I do want to say something about uncertainties, because it's misunderstood. We always have uncertainties. There's no crystal ball. Nobody has a crystal ball. And we need risk management to manage the uncertainties. That's what risk management is, right? Most uncertainty in climate impacts is due to humans. Let me say that again. Most uncertainty is due to human behavior. What will we do? Not due to climate models. Yes, there's uncertainty in climate science. There's uncertainty in economic models. That's not the really big top uncertainty. It's human behavior. And what are the uncertainties and outcomes if we don't take enough action? Well, it's either bad or catastrophic. So that's all I want to say about uncertainties. If you ask me a question, I could talk about it some more. It is something that is misunderstood and misapplied. There's also a precautionary principle that says we should not delay action because we don't have full knowledge. And here's a climate summary in 6 words, in 12 words, sorry. It's real, it's us, experts agree, it's bad, and there's hope. There's one more, lobbyists deny, and I'll talk a little bit about that in the next part. Okay, so that's the end of the first part of the talk. So, Devin, are there any questions in the chat?
No, but I actually came up with a couple myself. What my question really is, I've read some articles about that saying climate change is already past its tipping point. What are your thoughts on that?
So, I talked about tipping points before. It's more like this. It's more like death by 1,000 cuts. Sometimes there will be tipping points. For example, the melting of glaciers, and especially the Antarctic ice sheets, that if they start to melt, and there's evidence that the Antarctic ice sheets are becoming unstable in timescales that used to be measured in thousands of years, then hundreds of years, and now we're talking about tens of years. Okay, so if that happens, then that's a real tipping point. Restoring those ice sheets cannot happen for a long time. By a long time, I mean, hundreds or maybe thousands of years. So that's an example of a tipping point. For a tipping point as it affects human society, that is really just degradation. So I talked about all these kinds of disasters. They'll just get worse. So I think that we shouldn't emphasize tipping points are there. They're really serious. They can happen. But if we emphasize them too much, then that can kind of lead to climate despair, and I don't like to do that. So it's optimism, which is something I'm going to talk about in the next section. Any more questions?
I just sort of have another branch off of that. Do you think, what do you think is the most critical way to get, the general public on board with this? There seem to be a lot of skeptics still.
So that's huge. Hold that question until the end of the next part when I talk about exactly what you're discussing. That is a huge, huge, huge topic, and Fordham University can have a role in helping to correct that.
Amazing. All right. Well, I will hold that. But there's no other questions in the chat. If anybody, feel free to open your mic if you want to have a question right now.
This is Steve. I have a question. You might get to it later. In some of the solutions, we're talking about electric vehicles and batteries. Is there a clear understanding of the actual energy benefit of doing that, given what it takes to do those batteries?
Great question. Hold it, because I'm actually going to talk about that in a couple of minutes.
That's good. Well, it looks like we're all set to go to the next section.
All right. So this is part 2. So just to review, climate opportunity and risk action. So climate action. So why? Why do we have to do that? So just again, make sure we're on the same page at a 50,000-foot level. So we need to reduce global warming, avoid the worst climate impacts with many co-benefits, leave a livable world to our descendants, take advantage of opportunities, okay? And we're not going to be able to mitigate everything. Some people want to do that, and that would be great if it happens, but I don't think it's going to happen. So we're going to need to adapt what we can't mitigate to cope with the impacts of global warming that remain. And there's a word, resilience, that's important to aim at better adaptation. Okay, so first of all, it's setting the scale. Why do I say they're trillions of dollars? Well, there are lots of reports, and the reports agree. The scale is trillions of dollars. Here's a report by McKinsey, for example. Have a look. There are other reports. Well, I talked about lost opportunity. So there's a big lost opportunity problem. So I believe that the climate action scale for action, the potential is bigger than the Industrial Revolution and bigger than the digital revolution. That's this thing, okay, which replaced mainframes and opened up a whole new world. In the same way, I believe going to renewable energies will open up a whole new world economically and financially. And I believe it's bigger than the digital revolution, but it's going to be huge whether this is true or not. There is a buggy whip company problem, I call it. That's for companies that don't want to get on board with moving to a renewable economy for one reason or another. They're going to miss the train and lose the opportunity. So, buggy whips. Oops. And it's the same problem for countries that drag their feet, and there are some countries that are doing that and obstruct climate action. Okay? And in fact, renewable economy is ramping up now, and it's now unstoppable. So I just want to say that again. So acting now is cheaper than waiting. So this is an article that you can read, assessing the costs of historical inaction on climate change, and that is estimated to be about $500 billion a year of cost. That's additional cost by waiting rather than acting. What about people? What do people actually want? Well, most people actually want climate action. There's a partisan aspect to it, but on the whole, people want climate action. There's a department at Yale University called the Yale Center for Climate Communication. They take polls all the time, and people want action on climate. Okay, so I do want to talk about the international climate conferences and also national climate responses. So the three that I want to just briefly discuss are Copenhagen, Paris, and Glasgow. I was actually at Copenhagen in 2009. I was at Paris in 2015. I actually gave a talk there. And Glasgow was the conference last year. So starting in Paris, there was a Paris Agreement, and as part of it, each country pledges what's called their own nationally determined contribution, or NDC. So it's not a top-down thing, it's a bottom-up. Each country pledges what it thinks it can do and what it's willing to do as a voluntary contribution to avoiding the problem of climate change. It's great. It's not enough, but it's a really great start. And there were enhanced ambition announcements at Glasgow, which I want to talk about. So that's what countries do. The United States has one. Basically, all countries have them. So the way I would characterize the negotiations at these conferences is that they're steady and very difficult progress. For the first time, China and India made net zero pledges. Now, there are all kinds of issues about energy equity, which I'm going to talk about in a couple minutes, which are essential here to understand. But they did make net zero pledges, and that's very good. We need much more short-term ambition in order to realize the goals of these climate conferences and keep a livable world. And the time estimate is 2030. That's very few years where we really need to substantially increase our action on climate change. There's a recognition that climate is everybody's problem. Okay, climate is everybody's problem. A good news aspect is that there's less, but it's not zero, but there's less obstruction and also free riding, which means you let other people do the work, but you just benefit. And as a fact, all countries have to agree on international conferences, negotiated outcomes. Okay, so now I just want to show you a few graphs of data. These are the annual carbon dioxide emissions over time, starting in 1970, and the units are billions of tons of carbon dioxide per year. Okay, those are the units. The pink line with little uncertainties, that's the United States. So up to about 2004, the United States was number one. Next is the European Union. Next is Russia. And here's China. China has increased to where now China is the leading emitter. However, that is not the relevant statistic. The relevant statistic is the cumulative amount of carbon dioxide. Let me say that again. The relevant metric is the cumulative total amount of carbon dioxide in the atmosphere. That's what matters for global warming, because carbon dioxide, each molecule of carbon dioxide acts to heat the Earth up a little bit, right? Carbon dioxide stays in the atmosphere for a long time. The scale is 100 years, not for every molecule, but on the average, okay? So once you put a carbon dioxide molecule up in the atmosphere, it's just up there, and it's making the Earth a little bit warmer. So this is the cumulative amount of carbon dioxide from the United States. It's the biggest contributor. The United States is the biggest contributor. European Union is next. China is third. Under all scenarios, going forward, staying within the carbon budget, the United States will still have the biggest cumulative amount of carbon dioxide in the atmosphere. We have a huge responsibility, everybody, and it's because of this. So I've talked about the carbon budget. I'm going to show you a very complicated slide. I'm not going to be able to explain it very carefully, but if you look at the you look at the presentation, you can go through it yourself. So this shows the carbon dioxide budget here in gigatons, thousands of gigatons of carbon dioxide for different scenarios leading to different temperature outcomes. Okay, so we cannot go past this level of carbon dioxide cumulatively in the atmosphere if we want to stay within this temperature range. That's what it says. And when you look at this and you ask how much carbon dioxide is already up there and how much is left, there's not much left that we can emit and still stay within the 2 degrees centigrade rise in temperature or 1.5 degrees centigrade temperature. So this is the carbon budget. These are the data. It's a 2050 graph, but it's similar for 2100. Just, this is the best graph I found. I want to show you one more thing. This is a graph of the observed temperature, global temperature. You can see it's bouncing around, but it's going up. That's global warming. I want you to notice something else, that global warming follows closely the trend of cumulative carbon dioxide in the atmosphere. That's the proof, if there is a proof in science. Science doesn't deal with proofs, only mathematics, but as close to a proof as you can get that cumulative carbon dioxide is the cause of global warming. And you can also see the little fluctuations in here. That's the natural variation. The natural variation is small compared to global warming, and that's caused by human activity. And you can prove that too, literally by isotopic analysis of the kind of carbon that's in the atmosphere. Okay, so this is a really important graph. I'm going to have to skip over it now, but please have a look at it in the presentation if you have time. This is another important graph. This is the per capita greenhouse gas emissions, which is the same thing as energy usage, basically up to a scale. And I want you to have a look at it. This is the United States. Okay, we're talking about per capita 22 tons of greenhouse emissions. An elephant weighs 7 tons. So the average American emits enough for a couple, 3 elephants, right? This is European Union and Russia. This is China. So this shows the difficulty in what we're trying to negotiate internationally, because there's a carbon budget. I just showed you that. The per capita greenhouse gas emissions, which is basically energy usage, is smaller in developing countries than in developed countries, the United States leading the way here. And so that's a huge equity issue. Why shouldn't, so the average subcontinent Indian in a little village in India uses 1/10 the energy of somebody in the United States. Is that fair? Well, no, it's not fair. What moral reason would there be that the little village in India, somebody living there, shouldn't have the same energy as somebody in New York? Nothing. There isn't any. So that's the difficulty. That's why it's really difficult to get countries to agree, because there is an overall carbon budget. That's physics. We can't avoid it. So attaining some degree of energy equity by who gets to burn what in the next few years before we use up the remaining carbon budget and hit an unlivable world. That's the difficulty. So I've talked about a livable world versus an unlivable world. What does that mean? First of all, notice everybody talks about degrees centigrade. 1 degree centigrade is 1.8 degrees Fahrenheit. Okay. Paris Agreement, to which all countries agreed, was we should try to achieve a temperature increase relative to pre-industrial levels of 2 degrees centigrade and target 1.5 degrees. Disasters are much worse at 3 degrees centigrade. At a 4 degrees centigrade increase, we have an unlivable planet. I would not want to live on that planet. So one question that I'm sure you all have is, these numbers are small numbers, right? 1, 2, 3, 4. What can it matter? You know that between nighttime and daytime where you live, temperatures vary a lot, right? Between summer and winter, temperatures vary a lot. So how can this be reasonable? Well, the reason it's reasonable is because when temperatures go up during the daytime where you are, let's say, at nighttime it's falling somewhere else on the Earth, okay? When it's heating up locally someplace on the Earth, it's cooling down somewhere else. That's weather. So that largely cancels out. What is making the temperature go up is human activity. This is a measure of how temperatures go up. And because the Earth is so big, the Earth is really big, a small temperature increase is huge. That's why a small temperature change makes a huge difference. That's something which is not widely understood, but it's what is really the case. So by an unlivable planet, I just mean all the disasters I've talked about just get a lot worse. So at the latest Glasgow conference, if all pledges, these nationally determined contributions, are met, we can in fact achieve a 2 degree centigrade world. That was basically the Paris Agreement. We need to do better because there's a big difference between 1.5 and 2 degrees centigrade in terms of impacts, but it's actually good. So if countries carry out what they say they're going to carry out, things are not as bad as they used to be, which was a 3 degree world previous to Glasgow. So that's an improvement. That's good news. So I want to talk about scenarios for a second. There are many scenarios. We don't have a crystal ball, but what we do instead is we develop scenarios. They're called, there have been many scenarios. I don't have time to talk about them all, but they all boil down to this. If we really act on climate change, we'll have a good scenario. This measures the amount of carbon dioxide emitted. If we don't act on climate change in a reasonable way, then we're going to have a result which blows through the carbon budget and creates an unlivable world. That's simple. Scenarios are traditionally made out to the year 2100, but I would like to ask everybody this question. Ask yourself, have you ever gone to a Shakespeare play? Or do you know who Shakespeare was? Well, the answer I'm sure is yes for everybody. And here's a fact about Shakespeare. Shakespeare lived 400 years ago. So we're talking about 2100, that's 80 years. My granddaughter will still be around, I hope, in 2100. But really, we should be talking about several hundred years, and we don't normally do it. So where are we here? So in terms of the pre-Glasgow results, just from Paris, the amount of carbon dioxide emitted per year was expected to go up, especially for other developing countries. China going up, the United States and European Union were going down. So that's true. But remember, it's a cumulative amount that counts, and leadership really counts and so forth. But this isn't enough. This leads to a 3.5 degrees centigrade rise. What we need to get just a 2 degrees centigrade rise is for emissions to decrease substantially by 2050 and basically turn off. So we have to, by that, that's what I meant by the mission at the beginning in terms of reducing carbon dioxide emissions with all deliberate speed, eliminating them. That's what this means. If we get to 1.5 degrees centigrade, which is really a pretty livable world, we need to speed up now. Urgent speed up by 2030 is required. Substantial cuts in emissions are required by that time if we are going to get to a 1.5 degree world. And we will have to pull carbon dioxide out of the atmosphere in addition. So I urge you to, again, have a look at
Jan, it sounds like your voice just cut out.
Yeah, I agree. I don't hear anything.
to which cities, states, NGOs, and businesses subscribe for action on climate. It's substantial, it's necessary. Over half the people in the world live in cities now, and so this is a very important part of climate action. Businesses are starting to make net zero commitments. In terms of their net zero commitments, there are various types of emissions, scope 1, 2, and 3. Scope 3 is the most important. That's what I want you to remember, because it includes effects up and down the supply chain. And good news here is that Apple committed to be 100% carbon neutral for its supply chain and products by 2030. That's great news. So other companies have made these net zero commitments. The big question is, are they going to live up to these commitments? Because making a commitment is a good idea, it's great, and now they have to actually deliver. There are all kinds of actions by all kinds of NGOs. I mentioned environmental, faith-based, academic, and here's one by and investors. Here's one by the Sierra Club. It's called Beyond Coal. Again, Mike Bloomberg's name is here. He's been very active here, financing lawyers from the Sierra Club that closed down coal plants that were in violation of environmental regulations. Okay, so that's an action by the Sierra Club. Now, I do want to mention the reports, the IPCC reports, that because of all the bad news recently, have kind of lost the impact that we all hoped that they would have. That again, the three categories that I talked about: the science report that came out in 2021, impacts report that came out earlier this year, and mitigation that just came out a couple of weeks ago. I have actually right here an example of a mitigation report just to show you what it is. This is from 2007. This is a volume that I have on my bookshelf. The reports have gotten a lot fatter, so I don't have room on my bookshelf for them anymore. But this is the mitigation report from 2007. These reports are not written by the IPCC. IPCC has a small staff. People talk about the IPCC scientists. There's actually no such thing. What happens is scientists from universities, some NGOs and government labs and so forth get together in small groups and write pieces of these reports. Okay, there is a summary for policymakers that I urge you all to get. This is an example of a summary for policymakers. It's a very thin volume. You can read it. It's aimed at policymakers. All countries agree to every line in a summary for policymakers of each report. Okay, so these reports have political clout because all countries have agreed to what's in the, and so I recommend that you download them. They're free. Read them. I also want to talk about something called Project Drawdown. That is a comprehensive list of 100 different climate actions, studies with quantitative models, actions that are available now. Both costs and benefits are estimated, and the benefits far outweigh the cost. There is a book that I urge you also to get. It's the Project Drawdown. Here's the book. Okay, and what you'll see in the book is our tables. I don't have time to go through them now, but tables, for example, showing the huge benefits of opportunity benefits over costs by quantitative models, okay? And huge carbon dioxide reductions if we carry these out. And we need basically all of them. Okay, that's Project Drawdown. Very good reference. There is a simulator which was developed by MIT and some other people which is called En-ROADS. I highly recommend that you can download it and run it yourself. Here's what it is. It's a medium-sized climate model, which I don't have time to discuss, in agreement with mainstream climate models, both for science and economics. It's got 15,000 coupled differential equations behind it, okay? And it's got, the front end has these little dials, and you can move these dials. For example, here's one called energy efficiency, and you can move it to increase the amount of energy efficiency, for example. Okay, all kinds of actions. And then you can see what the result will be, okay, that's predicted by the model. Okay, and the temperature outcomes from the models are predictions of the models. They're not input to the models. Okay, En-ROADS. So I'm now just going to run through some examples. You already know them, but just to remind you of what we can do. What are some of these things? Well, first is solar energy. Solar costs have been dropping very rapidly, and according to an analogy to even Moore's law for the size of transistors, there are many types of solar energy. There's rooftop solar, there's concentrated solar, there's community solar. There's lots of research in solar energy, but right now solar energy is the cheapest form of new energy in many places on the globe. Solar energy. Wind energy. This is a graph of wind facilities in the United States. There's lots and lots of it, especially in the Midwest and the Northeast, a little bit on the West Coast, and starting to develop offshore also. Wind energy is a huge potential source of renewable energy, the wind. And when the wind blows, sometimes it's night and the sun isn't shining, but then the sun is shining, the wind isn't blowing. So these are complementary. Renewable energy is taking off. So I said a couple times that I thought that it was unstoppable. Here's a graph that kind of illustrates that. Worldwide renewable energy in terms of power, this is gigawatts, has been the preferred type of energy in new deployment as opposed to fossil fuels. And it's been that way for the last 10 years. We need a better electric grid in order to handle, for all kinds of reasons, in order to handle the renewable energies that are coming online. And there is a really positive set of studies that I urge you to look at, talking about a network of high voltage DC lines that are here. They can go along, for example, the interstate freeway system, interstate road system, and that can hook into the standard AC or ordinary power grid. That can take wind from the areas where wind is really prevalent and cheap and take it other places, and take solar energy and take it other places with a backstop of some sort. That can deliver energy with off-the-shelf technology at 12 cents a kilowatt hour. As cheap as the development that's going to be necessary to handle additional growth, keep the lights on, both for consumers and for industry. So, electric grid. Electric vehicles. Steve asked a question about electric vehicles. It is going to be necessary for climate action to electrify the system. And the answer to Steve's question is yes, it is actually does increase the amount of carbon dioxide saved and the energy that is going to be needed for electric vehicles and for batteries, which I'll talk about in a second, is something that's progressing. There are various car manufacturers that are announcing plans to shift to electric vehicles. This means cars, buses, trucks, and there are also hybrid electric vehicles where if you're just running around town, you have a little battery and you can run around town, and it's basically an electric vehicle. I have one of those. Nuclear energy is a complicated and controversial subject. I want to talk about something that's not normally discussed. That's nuclear fusion. Nuclear fusion basically works different from fission, does not have any of the problems of fission, that is to say, problems of potential proliferation, nuclear waste disposal, possible meltdowns, and accidents and so forth. But fusion works this way: you take two forms of heavy water And with high magnetic fields and high confinement magnetic fields, making them in the same vicinity, and at a very high temperature, you make them bang into each other, that produces energy. Okay, and fusion research has been going on for a long time. There is a standard joke which says that fusion energy is always 10 to 20 years in the future, no matter when you say it. That's been the joke up to now. This may be the last chance anybody has to make the joke, because fusion is now going to become commercial, I believe. There is a facility in France, a place called Cadarache, called ITER, which is there to explore the commercial feasibility of fusion, and companies are getting interested in fusion. I attended a symposium run by the White House. Unusual, having all kinds of businesses that were making really positive statements about investing in fusion energy. And there's lots of different kinds of fusion. I urge you to find out about fusion. Energy efficiency is huge. There's lots of low-hanging fruit. We waste a lot of energy. We don't need to waste a lot of energy. We can insulate buildings. We can use Energy Star appliances. There's lots of things that we can do for energy efficiency and heat pumps and so forth. So I urge you to find out about that. We can just reduce our energy use. Turn off the lights, right? Turn on the heat. So there are all kinds of ways of reducing energy. And there is something that I do want to talk about, which is carbon dioxide removal. So this is a complicated topic. There are lots of different types of carbon dioxide removal. We will need some carbon dioxide removal. And the statement that I make is a one-line statement, which is that for a livable world consistent with 1.5 degrees, we basically need something like 350 parts per million of carbon dioxide. So what does that mean? It means that the number of molecules in the atmosphere compared with the total number of molecules in the atmosphere is measured in parts per million. So for 1 million molecules, 1 part per million is 1 molecule out of 1 million, right? Well, carbon dioxide, we need to have 350 parts per million as a target, and there have been in the past, you know, before global warming started, about 350 parts per million for a livable world. Right now, there's 410 parts per million, way over the limit that we need. We will need to take out 60 parts per million of carbon dioxide. The ways to do it that are the least destructive are just forests, trees, switchgrass, poplar trees, things like that, regenerative agriculture, lots of different ways. There are also other ways which attempt to pull carbon dioxide out of the atmosphere. They don't scale yet and they're extremely expensive, but that's something that can be developed. Steve talked about batteries. Battery research is getting better and better. Batteries are decreasing in cost. There are all kinds of positive aspects of new kinds of batteries. I read the other day that, for example, lithium-sulfur batteries have just overcome a big technological hurdle with sulfur replacing cobalt. And there's lots of different kinds of batteries which are under investigation. Basically, a battery is it's an anode and then a cathode, and ions move between it or electrons move between it with stuff in the middle. There's all kinds of ways that you can tweak and change all these things, and that's a subject of great interest and progress. Stranded assets, we cannot burn all the carbon that's in the ground and still stay within the carbon budget. That has a huge impact for fossil fuel companies. It has a huge impact for your portfolios. So that's the topic there is called stranded assets. Assets are in the ground, that's carbon assets. There's a lot of evidence that at least 50% of the carbon that's in the ground, that's known resources, cannot be burned and stay within the carbon budget that I just talked about. Now I want to talk about a few other things that can be done. There are many, many organizations, NGOs. One of them that I especially like, that I'm a member of, is called the Citizens Climate Lobby. They advocate nationwide for a carbon fee and dividend approach to pricing carbon, where you put a fee on carbon at the source of extraction, that's coal mines, fracking facilities, and oil wells, and you take that money and give it back to people on a pro rata basis. when you do that, it stimulates the economy because people who actually don't have a lot of money, live month to month, spend the money, so it stimulates the economy, and at the same time puts a price on carbon that can and probably will lead to more renewable energies. Part of that effort is visiting basically staffers on the Hill talking about this approach. Whoop, wrong way. Climate action is becoming more and more prevalent, especially among the youth. There are marches. There was big marches in New York. Letters to the editor. This is an action by a brave person who had her baby and confronted Scott Pruitt in a restaurant, who was trying to dismantle the EPA under the last administration. Climate action is another thing. There is a database of climate lawsuits, many climate lawsuits. Who has responsibility here, right? And so many climate lawsuits have been filed, all different kinds of lawsuits. They're maintained in a database at the Sabin Center for Climate Law, run by a guy named Michael Gerard. And I urge you to have a look. One of the climate lawsuits which has been brought by youth against governments is called the Juliana case. Responsible climate journalism is a huge issue. Devin asked about that before. This is something that is a huge problem. Responsible climate journalism is being practiced more and more, especially by some newspapers. There are very excellent climate analyses and by reports, all kinds of things. One resource is the Climate Science Rapid Response Team. I'm a matchmaker for it, which has behind us about 150 climate scientists, members of the press, or people in government want answers to climate science questions. There's that resource. There are lots of reports. There's a report called Risky Business. This is a copy of it. Risky Business. Lots of reports that have been written by many organizations that talk about different aspects of climate change, mitigation, adaptation. I urge you to have a look at some of these reports. So the arts is a way to reach a lot of people that don't actually like data, right? And so music, photography, films, plays, all kinds of ways to reach people through the arts to act on climate change. Climate education is a huge topic. There are K-12 curricula now that have good climate information for kids, and for all of us out here. There are lots of resources that are available. If you want to know about climate science written by climate scientists in a way that's understandable, I recommend realclimate.org. And now it's time to talk about the other thing that Devin brought up, which I call climate denier, science denial, and risk denial obstruction. Okay, so there are 4 types of this. 4 types. I call them tranches. And we're talking about global warming here. So global warming does exist. I've shown you that it exists. There are some deniers that deny that global warming exists. They just basically distort the data. Global warming is caused by humans. Deniers deny that. There are some deniers that deny that. Global warming has severe impacts. I've already talked about that. There's some deniers that deny that. And finally, global warming can be mitigated and should be mitigated, and there are various deniers that deny that. So different people who are deniers are in these various tranches, sometimes more than one tranche. It's a huge risk. Climate action is obstructed by people that practice climate science and risk denial. A lot of it was fomented by the fossil fuel industry, especially during the 90s, by ExxonMobil. Lee Raymond was a key figure in that. There are some videos, some movies out about that. I urge you to have a look. There has been some movement from emphasis on these first 2 tranches to the second 2 tranches, but basically the tranches are still all there. There's a resource that you might want to have a look at. It's called Skeptical Science. And actually contributed to this also. So in skeptical science, there are over 100 climate myths, they're called, of things that people have said that are nonsense about climate change and global warming, and one-liner responses to them, and then responses that go into more depth. So I urge you to have a look at skeptical science. I have a book. The last chapter of the book in the second edition talks about climate change risk management. And there are also other resources. This is at the beginning on my credits. I was the editor of a climate change encyclopedia. I urge you to have a look at that. So this deals with all aspects of climate change, focusing on finance, economics, and policy, but also including many other related topics, written in a way that is accessible to people using a template, talking in plain language, of experts writing directly to the public. There's a new journal that's coming out called the Journal of Climate Action, Research and Policy. That is going to emphasize climate action, which is something that's new in climate journals. So that'll be out next year. I have actually been talking for some time about trying to establish an Academy of Risk and Opportunity, Climate Change Risk and Opportunity, to help galvanize business climate risk and evaluation, catalyze a new C-suite level profession, which I've been talking about, Climate Change Risk and Opportunity Officer, with some guidelines. I have a talk, you can see it if you want, and trying to get universities to sign up. So there are three aspects to this. Fordham is making significant progress toward this. I just want to say that. But the three aspects of this that I want to talk about that's going to be necessary for people to go into business, evaluate climate risk for business, and take advantage of opportunities are the three categories. One is risk management. That's standard. One is climate change. That's also standard, but usually not in the same department. And third, a number of specialized topics which are generally not taught and which should and need to be taught for people to really be able to function well in that kind of position. There are all kinds of details that I don't have time to go through. Each one of these words has a number of lectures behind it, and so that'll be in the presentation if you want to have a look. Okay, so there's much more in the climate action portfolio. I said that climate action is really 100 things. Lots more. I don't even have time to list them all. Decarbonizing heavy industry, for example, steel, shipping, aviation, cement. Okay, eating less meat. The meat industry contributes 15% to the global warming problem, or grass-fed beef. Developments in hydrogen, there's hydrogen economy with renewable energies providing the energy in order to get the hydrogen in the first place. All kinds of nuclear energy progress past the current generation of nuclear reactors, which are probably not going to go anywhere. But there's a fourth generation nuclear fission research, which I think is very promising, which uses high energy particles in fission, which are big nuclei which break apart and can actually eat the nuclear waste from present-day light water reactors. Geothermal energy is another one I haven't had time to talk about. Heat pumps that just move energy around and don't generate energy with electricity. Cogeneration, which takes waste heat and turns it into electricity. Lots of possible ways of generating energy, and we're going to need all of them in some way or other. Reduce, reuse, and recycle, extremely important. That's called part of what's called the circular economy, which is going to be also necessary to adopt. Somebody mentioned plastics. Yes, indeed, plastics contribute about 7% to the problem because they're based on oil. We need to reduce use of plastics. That's an extremely important thing as well. Offsets are very popular. That means you get somebody else to do the work. You don't actually do it. You just pay them to do it. So that's a kind of a tricky subject. You know, is it some offset really going to reduce carbon emissions or not. So there are gold standards, and this is a tricky thing. Part of one of the ways of talking about a carbon tax is to use carbon markets. Those are some kinds of offsets, basically. And so these are tricky topics. I'm not going to have time to talk about them. I recommend not talking about geoengineering or solar radiation management, where you basically try to make the whole world look like Los Angeles looked when I was going to school there, in order to cut down the sun radiation. It's got all kinds of side effects. Okay, so that's the end of the talk. Here's the quiz again. So what do you think about the opportunities and risks involved with climate change? Okay, so I hope you've been thinking about that. So I'm not gonna ask you what they are or anything, just for yourself. And did anything change? Okay, so these are the last words of the talk. Climate change, opportunity, and risk management. I mentioned at the beginning 3 words: optimism, courage, and persistence. So I want to say why I did that. First of all, optimism. So people ask me all the time, Jan, are you optimistic? And I say, you know what? I don't have a choice. Why is that? When my grandchildren get to be old enough so they say, Grandpa, what did you do about climate change? I'm not going to say, well, I gave up and quit. Okay? So optimism is really essential. Okay? Courage. Each of the things that I've discussed is a very difficult thing to implement. There are all kinds of technical problems, policy problems, regulation problems, obstruction problems, disinformation problems. It takes courage to get up and do that. I'm actually a timid person. It actually took some courage for me to learn how to give talks like this, right? Okay, so courage is another one. And persistence. So this action on climate needs to be ramped up sooner rather than later, but it's not a sprint. So we're going to have to continue acting on climate for many years. It's persistence is one of the 3. So optimism, courage, and persistence. And we all can help. So look for climate action opportunity, everybody. Apply, promote climate risk management. Okay? And if you're already active, then thank you. Okay, so that's the end of the talk. There's an appendix which I can use as resources if anybody asks me questions whose content is in there. But that's the end of the talk.
We do have a question in the chat. I will read it out for you. So this is from Walter. A few observations about carbon taxation, then a question. So 1, regressive effects of carbon taxation are likely hard to affect offset. Number 2, big oil lobbying has now shifted strongly to favoring carbon taxation. Then number 3, a number of respected pro-climate political scientists, Leigh Stokes, Meadow Mildenberg, etc., have argued that carbon taxation has poor efficacy as a policy tool compared with other approaches. And then finally, the question, should we be careful about equating climate awareness with support for carbon taxation? Okay,
so let me try to deal with that. So it is known. So if you look at the En-ROADS simulator and you start moving these dials around, you will find out that carbon pricing is probably the single most important thing you can do. So on a quantitative basis, carbon pricing is really important. That's the first thing. Second thing is carbon taxation can be regressive. Why is that? Because it raises the price of gas. People need gas to get to work. If you're poor, you don't have the money to pay for that. So it can be regressive. That's one of the reasons I really like the Citizens Climate Lobby fee and dividend approach, because when the gas price goes up, people get money refunded, not refunded, just, okay, refunded to them from the fee, which basically pays for the increase in the price of gas. And for people that don't have a lot of money and don't actually, that largely covers, or actually more than covers, studies have shown more than covers the increase in the price of fuels and that which is passed down the road. There are some exceptions, for example, on farms where people have to drive a lot, and there's a lot of, because it's rural and they have tractors and so forth. And so you can have cutouts for people like that. So you can, in fact, make what amounts to a carbon tax, if it's a fee and dividend approach, equitable and just. Okay, that's one reason I really like that approach. It can happen, and whoever asked the question is correct, that a carbon fee can be, tax can be regressive. You want to avoid that. The third point is whether we should, in fact, promote a carbon tax or fee. And I think the answer is yes, because it does stimulate other carbon approaches. But again, I like to use the word and not the word or. So there's no silver bullet. We need to adopt 100 different climate actions, and carbon pricing can be and should be, I believe, an integral part of that. It is also true that fossil fuel companies have started to talk about carbon tax as something largely, I believe, because that's on their part, is greenwashing. So a carbon tax on their part just simply means that that cost would be passed down the line to the consumer. But they actually have a point. And the point is that if it's implemented the right way, it can be an equitable policy. Other questions?
Yeah, I just want to share. I downloaded a book that's written by Bill Gates, How to Avoid Climate Disaster. And one of the things that I learned from it, that cement industry is one of the biggest contributor of the CO2. So what is the level of commitment from the, I mean, I've seen in your slides that Apple is committing to reduce, the carbon footprint by a certain amount. So what is the level of commitment from the cement industry?
Great question. So that's been discussed now for a long time. If you put carbon dioxide in cement, you can sequester carbon dioxide basically in the cement. It's expensive. However, cement is a big contributor to it has a big footprint. I don't remember the percentage of the percentage of cement. It's maybe 10%. I don't really remember.
Well,
but yeah, it's big.
According to Bill Gates, it's more than 10%.
Well, whatever it is, it's a big contributor. Yes. And yes, cement is something. So it's one of the things that I listed in the, in the last slide. Yes, it's a biggie, and it has to be treated along with all the other things that I talked about. So in addition to cement, the difficult things to, so there's some things which are easy kind of to cope with, and there's some things which are difficult. One of the other difficult things are high temperature industrial processes. So there, for example, you need a special kind of, solar energy, concentrated solar that can get up to that kind of temperature, or hydrogen that can get up to that kind of temperature. But so industry is another place where we need decarbonization, but it has to happen. So yes, cement is a big one. You're right. And so, Bill Gates was right about that. That's been, we've been discussing that for 10 years now. Yeah. Other questions? All right. Well, it's an hour and a half, so that was the canonical amount of time I had. So
can I ask a favor? Can you email your presentation? It'll be a great thing to have it handy.
Oh, thank you for asking. So you have my permission, Fordham, to post the presentation someplace and then send the link out. Is that something you could do?
Yeah, I will be sending it along with the recording once the recording process.
Okay.
Thank you.
Okay, great.
And this is great. Thank you for allowing us to use that video, the presentation, and I really like the job you did. You covered so much, and it's food for thought for everyone at the school. Thank you.
Thank you so much. Thank you.
Okay, I appreciate